Good morning, guys. Now, today our topic is ellipse. Okay, after completion of parabola, we are going to read today ellipse. And in ellipse, what are the methods we have and what are the topics we have today we discuss. Okay, the weightage of ellipse. The weightage of ellipse in intermediate board of examination, you may get two short answers, that is 4 plus 4, 8. We will get 4 marks questions from ellipse. Okay, in conic section we have 3 chapters. One is parabola, and second one is ellipse, and third one is hyperbola. Okay, now in coming to ellipse, ellipse and parabola and hyperbola are the similar topics or similarity between them. Similarity we see that. Okay, what are the similarity we'll see in further classes. Okay, now coming to our point, ellipse. In ellipse we discuss. In ellipse, what are the topics we discuss in ellipse? Today we are going to discuss definition of ellipse. Definition of ellipse. What is a definition of ellipse? And standard form of ellipse. Standard form of ellipse. Standard form of ellipse. And third one is various types of ellipse. We can see that various types of ellipse. Okay, now today class only we discuss definition of ellipse and standard form of ellipse. Okay, now what is a definition of an ellipse? What is a definition of ellipse? We know that in previous class we discussed, suppose in conic, if it is real axis which is in the form of parabola, it is a right-handed parabola, which is a right-handed parabola. Okay, which is right-handed parabola. Now, when we have another parabola, if left-handed parabola, it is a left-handed parabola. How it is forming means rotating the axis. Rotating the axis, we get different types of parabola. When we have right-handed and left-handed parabola, when joining these two, we form a ellipse. We form a ellipse. Okay. Now, in parabola, here inside is focus is any point, and parabola it is P and it is M. We know that SP by PM equal to E is eccentricity. Okay, eccentricity. Now, depending on this concept, now the definition of parabola, definition of a parabola, the locus of a point, whose distance from whose distance, the locus of a point whose ratio of distance from a fixed point and as well as a fixed straight line, is less than 1 is called ellipse. Okay, clearly we see the definition of ellipse. The locus of a point whose ratio of distance from a fixed point as well as a fixed straight line is less than 1 is called a ellipse. Now diagrammatically I will explain this definition. Suppose it is any conic, here is a point P and here is locus. Okay, now we know that this is clearly M. Now this is, we can take as SP by PM equal to E, where E is less than 1. SP by PM. It is a ratio. The locus of a point whose ratio? It is 1 ratio. Distance from a fixed point, and as well as a fixed straight line, is less than 1 is called an ellipse. Okay, these condition already we seen in a previous class in parabola, where SP by PM equal to E, where E equal to 1. Now here E equal to 1 we get is a parabola, and V less than 1 it is ellipse, it forms ellipse, where E greater than 1 it is a hyperbola, and where E equal to root 2 it is a rectangular hyperbola. It is rectangular hyperbola. Okay, it is a rectangular hyperbola. Where E equal to 1 parabola, E less than 1 it is ellipse, E greater than 1 hyperbola, and E equal to root 2 it is rectangular hyperbola. In our syllabus we don't have rectangular hyperbola, only we have the E greater than 1 hyperbola. Today only we discuss E less than 1 is an ellipse. So that is SP by PM equal to E, where E less than 1. Okay, now in parabola we see that only this means here x is symmetrical, here x axis is symmetrical. In this equation is y axis is symmetrical. Okay, but in ellipse here x and y are both are symmetrical axes. Okay, x and y are both symmetrical axes, and ellipse diagram shows that systematical and symmetrical figure. Ellipse is a systematical and a symmetrical figure. Okay, the which is in a ellipse shape. We can take as one example, better example or best example is egg. Egg is which is in shape of ellipse. Okay, now next we have that point. Before going to standard form of a ellipse, we can see one harmonic conjugate points. Here we have a definition: harmonic conjugate points. One of the important definition, harmonic conjugate points. Depending on these definition, we can derive the standard form of ellipse. Okay, now suppose here there is any line joining points or line segment points, here A and here B. Okay, these A and B can be divided by, the point is P. A is divided, AB divided by P internally. P lies between A and B, so AB can be divided by internally, that is by P. Now here any point is Q, it divides the AB as usual by externally. This divides by externally. Okay, so this is divided by externally. It is divided by externally, and this is divided by internally. It is divided by internally. Okay, now where P and Q are called conjugate harmonic points, where P and Q are called conjugate harmonic points. Okay, now what is the definition? If the two line joining points, AB can be divided by can be divided by one is internally, another one is externally, is externally, is called is called harmonic conjugate points. Harmonic conjugate points. So this is a definition for harmonic conjugate points. Okay. Now harmonic conjugate points means it divides the line segment into one point by internally, one point by externally. Okay. Now next we have standard form of ellipse. Standard form of ellipse. Standard form of ellipse. Standard form of ellipse. And what is a standard form of ellipse? Clearly, we know that by standard form of ellipse is x square by a square plus y square by b square is equal to 1, where a greater than b. X square by a square plus y square by b square equal to 1, which is a standard form of ellipse. Okay, to derive these formula or standard form of ellipse, first we draw one diagram. We can draw an ellipse diagram. So which is any y-axis and which is any x-axis. Okay, which is any y-axis. Now so which is a ellipse? It is a ellipse. Now which is x-axis and this is y-axis. This is y dash. Okay. Now in every ellipse or in every conic section, we have the center C. Here center is C, nothing but RG, and the fixed point is always S. Is called focus. Fixed point is always called focus, and here the vertex. Here vertex is A. Okay. Now here in ellipse we can see the double forces, means another forces and another vertex. Why? Because here joining the right-handed parabola and left-handed parabola, we can form an ellipse. Okay. So depending on that, we may have that is two forces and two vertices. Here another forces is S dash and another vertex is A dash. Okay. Now next, after getting center and forces, vertices and the directrix, here L equal to 0, and here also we have the directrix L dash equal to 0. This is a directrix, and another foot, here foot of vertices is Z and foot of vertices A dash is Z dash. Okay. Now here this is B and this is B dash. Okay. Now by using here, now here S to Z, S to Z, SZ is a line joining points, and here A divides the SZ into internally, and here A dash divides SZ externally. In just now we discussed harmonic conjugate points. The harmonic conjugate point concept will be used here. Now here SZ is a line joining point, and A divides the SZ into internally, and here A dash divides SZ as externally. Okay. So therefore we can take as the ratio, we can see the two cases. One is divides internally and divides externally. Okay. So depending on that, now if SZ is divided by A internally the ratio is E is to 1, then that is we can take as the ratio is S to Z, so that means here SA by and SA by AZ, so that is SA by AZ is equal to E by 1. By doing cross multiplication, SA equal to E into AZ. Now we can consider any distance from the center. Okay, which point we are taking, or we consider any length we can take as from center. Okay, so we have the SA, we need SA distance, so we can subtract the CA minus CA, so we get SA, so that is CA minus CS. CA minus CS is equal to E into the AZ also can be taken from center, so that is CZ minus CA. It can be CZ minus CA. So which is say some equation 1. Now AZ can be divided by A dash externally. Now if SZ is divided by A dash externally, so externally, then S A dash by A dash Z is equal to E by 1, then implies S A dash equal to E into A dash Z. How it means here S to A dash by the distance from A dash to Z. Okay, S to A dash and A dash to Z is equal to E by 1. So E by 1 means we get S A dash equal to E into A dash Z. So then implies here S A dash. Here S A dash means how we can find out S A dash, again we take as a center. So S to A dash. Here S to A dash we have CS and CA dash. So that is CA dash plus CS is equal to E into A dash Z. A dash to Z we can consider as from center to. So that is CZ and CA dash. So again CZ plus CA dash. So say this is the equation 2. So this is an equation 2. So we found two equations, equation 1 and 2. So to seeing that equation 1 and 2, we can do any modifications or any operation on these two equations. Suppose I am doing 1 plus 2. So suppose I am doing here 1 plus 2, here minus CS plus CS will be cancelled, and here CA and CA dash will get. Okay, now that is then implies CA plus CA dash is equal to, where E is same, now where E is taken as common, and this A and this A will be cancelled, we get 2CZ. So here CA and CA dash will be same. How it is same means this distance and this distance will be same. So we can consider as these distance completely it is A, and also this is distance completely A. So it is totally A plus A, it is 2A and E into 2CZ. So these two cancel, where Cz equal to A by E. So Cz equal to E by E is nothing but equation of directrix. It is a equation of directrix. What is the equation of directrix? This is x equal to A by E, which is the equation of directrix. Which is the equation of directrix. Which is the equation of directrix. Now, when we do simplification here, 1 minus 2. Here in first case we adding two equations. In this case we are doing subtract. So 1 minus 2, when you are doing 1 minus 2, this here will be same, so it will be cancelled, and minus yes, this plus become minus, so this CS and this CS get minus 2 CS. So that is minus 2 CS is equal to, here E and E will be taken as common, and now here Cz and this Cz will be cancelled, and this is minus here and this is plus become minus, and minus here become, so it is minus CA and minus CA dash. Minus 2 CS equal to E into, it is a minus 2 minus will be cancelled, these two cancel, so C2S equal to this is A. So that is focus is nothing but AE comma 0, and this is minus AE comma 0, and this vertex is A comma 0, and this vertex is minus A comma 0. Okay, here we get these values, and we know that standard form, that is SP by PM equal to E. Now when you are doing simply squaring on both sides, SP square equal to E into PM square. So S2P, where P is any point on ellipse, this is x1 y1. So S2P is a distance. Okay, this is some any point M. Okay, now to simplification, this is x1 minus AE whole square plus y1 minus 0, so that is y1 square, and E square into PM square. P2M square is nothing but perpendicular distance. Okay, it is a perpendicular distance. Where it is taken from perpendicular distance means, that is formula ax1 plus by1 plus c by square root of a square plus b square. So that is, here we take as x1 minus a by e whole square by square root of 1 square. That is a perpendicular distance. So x minus a by e. Okay. Now after that, by conclusion, squaring on both sides, this value x1 square plus a square e square minus 2x1 ae plus y1 square is equal to, now doing simplification here, this e square become here, so that is e square x1 square plus a square minus 2x1 ae, and this e square will be cancelled. Now these value become cancelled. When is here take it as x1 as common, we get 1 minus e square equal to, when take as here a square as common, we get, this can be negative, so that is 1 minus e square. Sorry, here we have y square, so this is y1 square equal to e square into a square into 1 minus e square. So divide both sides by a square into 1 minus e square. So that we get x1 square by here 1 minus e square and a square into 1 minus e square plus y1 square by a square into 1 minus e square, and this is 1, and this value become cancelled. Here x1 square by a square and y1 square by b square is equal to 1. So where since b square equal to a square into 1 minus e square. Okay, now which is the standard form of a parabola. Okay, guys. Now, very important in the board of examination intermediate. Clear? This is the standard form of an ellipse. Next class we can see the various types of ellipse. After completed various types of ellipse, we go through the problems. Okay, I hope you guys will be understand. If you have any doubts, you can subscribe my channel, and you can ask any doubts.